Hello. Today we're going to talk about Module 8 quadrilaterals. Quadrilaterals in this unit just focus on the different characteristics and properties of quadrilaterals. Well, what are quadrilaterals? Quadrilaterals are figures or polygons with 4 sides. Now, depending on the sides depends what happens. So I'm going to kind of put it into a little chart right now, is that you have over here, you have this big category, call your quadrilaterals. It breaks up really into 3 subcategories. Way over here, you have a kite. Not much happens with a kite. A kite just basically has your diagonals are going to be perpendicular. It has the opposite angle is congruent. But when we're talking about it on the kite, what you're talking about is what I call the hinge. You have the top pieces here that are congruent, which is also corresponding sides congruent. But with this corresponding sides congruent, it talks about the top being congruent and then the bottom being congruent. This is the hinge. I call it the hinge, is the opposite side being congruent, because the top and the bottom aren't. The top and the bottom are not, because you could have a really tiny top and a really long bottom. It will cross here with our diagonals and make a 90 degree. The only thing in this that's congruent are these 2 little side pieces on the hinge with the kite. We don't do much with the kite as we do with the other things. Then we have a parallelogram. With our parallelogram, he breaks down into basically other figures. Parallelogram, depending on the characteristics, breaks down. First of all, when you just have a little parallelogram by himself, he's got a lot of characteristics. He has, I'm going to draw him here, he kind of looks like this, like he's been squatted over a little bit. He has your opposite sides are parallel. That means this side is parallel to this side, and this side's parallel to this side. So he has two pairs of those opposite sides being parallel. Also, those 2 sides are congruent. So not only are they parallel, but now this side's congruent to this side, and this side's also congruent to this side. We have our opposite angles are congruent. And again, there's 2 different pairs and then they're opposite. Unlike here, it's only the 1 pair. Here it's 2. So his angle is congruent to this angle and this angle's congruent to this angle because your opposite angles are congruent. Then we have our diagonals and they bisect. That means when these diagonals come across, this piece and this piece are congruent. This piece and this piece are congruent. They are not the whole diagonal is not congruent to the whole diagonal, just the bisecting pieces. Okay? So then when we move forward from here, we say, hey, if we take this parallelogram and we knock it straight up, then you get a rectangle. So what's unique about this with our rectangle, and our rectangle looks like this, what's unique about our rectangle is he's got all these properties. He's got opposite sides parallel, opposite sides congruent, opposite angles congruent, diagonals bisecting. But he adds on another property. With the property he adds on, he now has where I have 4 right angles. And now because he's sitting straight up, the diagonals bisect, but the diagonals are also congruent. So he's going to have these 4 right angles in here. And now the whole diagonal is congruent to the whole diagonal. But he's also all the things listed up here. The parallelogram also breaks down to our rhombus. Our rhombus is a parallelogram, and the only thing unique about our rhombus is it has 4 congruent sides. Well, not the only thing unique. 4 congruent sides. So all these sides are congruent. It's like a little mini parallelogram. But because those 4 sides are congruent, the diagonals now are perpendicular. So that means in this right here, when I have my diagonals, right here in the center, is going to be a right angle, which means all your right angle properties hold true. So that means the Pythagoras come in, and it also means that SOHCAHTOA can come in. That typically happens with a rhombus. A rhombus that typically happens with, because they know the diagonals are perpendicular in the middle, so sometimes to find the side, they'll give you one of these pieces here. It also has the unique aspect is that we still have that our opposite angles are congruent, but now the diagonal bisects the angle. I'll put diagonal bisects angle. That makes more sense. The diagonal bisects the angle, which means when the diagonal comes across, this piece and this piece are congruent. This piece and this piece are congruent. On the other side, not congruent to the other ones, they're congruent and they're congruent. But again, because he's long and squatty, they're not equal to each other. And your diagonals still do bisect, but they bisect with that perpendicular. So they still have opposite sides parallel, opposite sides congruent, opposite angles are congruent, and now they bisect. Diagonals bisect and are perpendicular. Okay, so it adds that stuff in. Then our last little parallelogram is when these two come together. So when these two come together, that's where you get your square. A square, by definition, is a rhombus and a rectangle. Which means it has all these property here, 4 right angles, diagonals congruent, 4 congruent sides, diagonals are perpendicular, diagonals bisect angles, opposite sides parallel, opposite sides congruent. He's like the end-all everything product, okay? When you're looking at this chart, a square can be any of these. And you have to be careful because sometimes they ask you the question, which of these characteristics best describe the figure? So you're looking for these things here at the bottom that are unique just to the figure. Just to the figure. So you got to be careful with that because every parallelogram, these are all parallelograms. He's a parallelogram who? He's a parallelogram who? He's a parallelogram who? That comes back that has all these figures. So if you're looking for something specific to a rectangle, then he's going to have all these things plus 4 right angles and diagonals congruent. So you got to be careful with that. The third guy is our trapezoid. Let me pull back up here, sorry. Is our trapezoid. Our trapezoid, just general basic old trapezoid, just has 1 pair of parallel sides. Not much going on with him. It would just be that. He can look something like this because he only has the 1 pair of parallel sides. He could look like this because he's got the 1 pair of parallel sides. Where he gets unique is when you throw in the isosceles trapezoid. Because like your isosceles triangle, now he's got properties that are congruent. So with your isosceles trapezoid, he always looks like this. These things right here are called legs, and your legs are congruent with an isosceles trapezoid. You also have here the base angles because of the isosceles. The base angles here are congruent, and the base angles at the top are congruent. Not congruent to each other. These two are congruent to each other. These two are congruent to each other, just like your isosceles triangle. So if your sides are congruent on the isosceles triangle, then down here is congruent. If your sides are congruent, then up here is congruent. So that's where the isosceles trapezoid. Do not forget that when you're solving some of these properties, because these are parallel lines, here's 180 degrees between the parallel lines. It's your consecutive interior angles. These two here are going to equal 180 degrees. But if he's 50 He's 130, he's 130, he's 50. Okay, so you got to think about that. Good luck on your test. Email or message me if you have any other questions. Thanks.